Welcome to AI Frontiers, the evolution of computer science learning. Today, we explore the cutting-edge breakthroughs that are redefining artificial intelligence capabilities. Modern AI systems now demonstrate uncanny abilities, predicting hurricane paths with precision, diagnosing rare diseases from scans, and even composing original music. These machines have moved beyond rote memorization into realms of reasoning, adaptation, and creativity through advances in computer science learning research. Computer science learning serves as the foundational engine powering today's AI applications, from voice assistants to autonomous vehicles. Researchers are tackling critical challenges, developing smarter models that learn faster while maintaining trustworthiness. This episode introduces the teams pushing these boundaries. The field has evolved from traditional static AI systems, like rigid librarians, to dynamic modern approaches where models actively learn, predict, and create. Three key areas drive progress. Statistical learning forms the foundation, deep learning builds layered neural networks, and reinforcement learning enables trial and error adaptation. Model generalization addresses the shapeshifter problem when AI fails on unfamiliar data. Li Zhang's team employs diffusion models to generate task-specific parameters dynamically, while Zhuo He developed time-aware causal frameworks that give AI contextual memory, transitioning from memorized maps to the ability to draw new ones. Energy efficiency breakthroughs are making AI more sustainable. cs.LG's Pathway-based Progressive Inference activates only necessary model components, like a pianist using just their fingers. Ibrahim Ahmed's EQuaRX compresses intermodal communication, similar to replacing HD video with efficient Morse code transmissions. Interpretability research cracks open AI's black box decisions. Zhongtian Sun's causal hypergraphs reveal how model adjustments propagate, while Min Lei cross-validates AI outputs against established knowledge, mirroring how doctors verify diagnoses with medical literature. Key findings reveal astonishing capabilities. Daniel Wergaft discovered transformers naturally adopt Bayesian strategies during training. Tung Nguyen's PhysX model learned physics from natural videos, while Christian Delgado exposed synthetic data's potential distortions despite its utility. Spotlight on PhysX. Tung Nguyen's team achieved a scientific breakthrough by tokenizing physics simulations, translating natural laws into a language AI understands. This transformer model successfully predicted fluid dynamics anomalies later confirmed in lab tests. PhysX represents more than a tool. It's a collaborative partner bridging quantum and cosmic scales. The model has corrected human equations and may help formalize undiscovered physical laws, with applications from drug discovery to climate modeling. The human story behind PhysX reveals the iterative nature of AI development. Particle physicist Tung Nguyen compared training to teaching calculus to a toddler, until the model began improving researchers' own equations, demonstrating unexpected capabilities. Future directions point toward unified intelligence systems. Shriyank Samvanchi's neuromorphic hardware could make edge devices as powerful as data centers, while federated foundation models preserve privacy across institutions. Algorithm hardware co-design promises optimized performance. Today's breakthroughs blur boundaries between machine and human cognition. As Bayesian transformers and physics-aware AI emerge, critical questions remain about responsible implementation. Listeners are encouraged to explore referenced papers and join the conversation using #AIFrontiers. This presentation was synthesized using GPT DeepSeek models with TTS via OpenAI. While human experts reviewed content, potential oversights may exist. All references are provided for further exploration of these groundbreaking developments. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.